Good morning. My name is Mr. Foster. I am a teacher, as you know already know. What I'm going to presenting is problem-solving techniques. Now, the thing is, I don't think I have a friend to teach it to, but if I had a friend, this is exactly the way in which I would explain it. I would even use a piece of paper or anything because I think it's important that someone can actually see what I'm talking about. So, for problem solving, there are many other techniques that can be used, but for mathematics, I think the one that works best is Polya's problem solving model. It can be adjusted in certain ways to accommodate us when we have other kinds of problems, maybe word problems, like the one we're going to check out today. But Polya's problem solving model has only 4 steps, and that's why I think I like it so much. So the first step to Polya's model is understanding the problem. By understanding the problem, we are simply saying that we must identify what needs to be solved. We need to know exactly what we need to do, what is the objective of this whole problem. And if we don't know that, I don't think we can even go on to the next step. And so the first one, I think it's the most important step in solving any problem. The second one is devising a plan. By devising a plan means thinking about all the skills, all the techniques that you do have or that you've already learned, and come up with a plan that you can use to actually solve the problem. So if you do not come up with a plan, chances are you're going to skip a step or you won't be able to go directly to the problem that you need. Then we have carrying out the plan. With carrying out the plan, this is where you actually, the plan that you did come up with, this is where you apply those skills, you apply those techniques, and use what you know, use what you've learned. So prior knowledge is very important in this step, because if you do not have any prior knowledge, then you won't be able to solve the problem as you need, and then as you need to. And then the last step is reflection. So reflection is basically for you to look back, reflect, does your answer seem reasonable? Does it seem like you've got the right answer? Did you solve the problem? Those are the kind of questions that you'll ask yourself in that very last step. So those are the only 4 steps to Polya's model, and I think they work quite well with mathematics. Now we have a problem. I mean, we have an example of a kind of problem that I would perhaps want a friend to be able to solve, and if he or she can apply these steps, I think he or she will be okay. So let's look at what it says. It says that the perimeter of a rectangle is 448.8 centimeters. The length of the rectangle is 3 times its width. They want us to determine its dimensions. So, in understanding the problem, we must know exactly what they gave us. We must know exactly what do they want us to find. So, we have the perimeter. They want us to find the dimensions. So, in our first step, we know exactly what we need to find, which is the dimensions. The second step, which is devising a plan, means to come up with a plan on how we're going to solve it. Now the thing is, with devising a plan, in a word problem like this, you're going to have to consider another step, which I would call symbolizing. You know, so you make an image out of the information that you have. You draw an image, and you use the information on the image to actually try and help you. So the first one would be to draw a rectangle, because essentially that's the shape that we're working with. The first thing that we must understand is that they did not give us a width, they did not give us the length, but they did tell us that the length is 3 times the width. So we're going to give it a name. Okay? So I will give the width the name of x. And if the length is 3 times the length of the width, obviously it would mean that this is 3x. So now we can check, now we can start devising a plan. With devising a plan, we know now that we have some dimensions. In the plan, what we can do is, the first thing, we can use our formula of calculating the perimeter to find the value of x. After that, we can substitute the value of x within our dimensions here, or within these values, and then we'll actually be able to find the dimensions, which is what we're actually trying to solve. So let us carry out the plan. This would be us carrying out the plan. The perimeter would be equals to 2a plus 2b In this case, we can choose anyone to be A, we can choose anyone to be B, nothing will be changed. So 2 times, let's choose 3x to be A. So 2 times 3x plus 2 times x. So our second x would now be B. From there, we just do the mathematics. Oh, not to forget the parameter. So another thing is they did give us the parameter. We must make sure we include it in our solution. So 448,8. So we'll just continue up until we can find x. This would be 448,8. 2 times 3x, 6x. 2 times x is 2x. This would be 8x. That would be 448, and then obviously to get rid of the 8, we'll just divide both sides by 8 to get rid of that 8, and then essentially x would be 56,1 centimeters. Now that we have found the value of x, I think our problem is almost done. We just have to make sure that we actually answer the question. The question wants us to determine the dimensions. So we have to say what is the width and what is the length. So in our case, I'll just do it on the side. The width, which is x, is equal to 56,1 centimeters. And then our length would then be 3x, which is 3 times 56,1, which is then 168,3 centimeters. So in the end, now we can check. After carrying out the plan, we look back, we check, did we actually solve the problem? Did we get the right values? Does the values make sense? We can check by replacing the x and the 3x, and we can use the formula again, and I'm sure we'll be able to get 448.